Hi. In problems of counting possibilities, the most useful tool for beginners is a tree diagram. And through the next few examples, I will show you how to use it. The first basic task is to count outcomes if we are tossing two coins. In the beginning, we are going to write the possible outcomes for the first coin, and we are going to call it the coin 1. We know that the possible outcomes are heads or tails. And I'm going to denote those possibilities as H and T. And now I'm going to draw two branches below those letters. And now these two branches represent two possible outcomes. Let's do the same thing for the second coin. In this case, the branches for the coin 2 will be attached to the branches for the coin 1, like we are forming the tree. Okay, and now we have all the possible outcomes, and if we want to determine the number of those possibilities, we are going to count the branches from the coin 1 to the coin 2. So we have the branch below the letters HH, and that represents the first outcome, heads and heads. And we're going to do the same thing for the other outcomes. HT, heads or tails. TH, tails, heads. And TT, tails, tails. In total, it will be 4 possible outcomes. Okay, I think that was easy. Now, let's do the same thing for the second example when we are dealing with 3 coins. The same procedure. The first coin has 2 branches, 2 possibilities, heads or tails. The second coin, 2 branches, heads or tails. And the third coin will also have those 2 branches. And again, finally, we are going to count all these branches. How many branches do we have? The first branch is HHH, etc. And if we want to, of course, name the outcomes, again, we can write all of them here. THH, THT, TTH, and TTT. Altogether, 8 outcomes. Now let's jump to something more interesting, like food, and start counting meals. A restaurant offers pie, ice cream, cake, pudding, or fruit for dessert, which it serves with coffee, tea, or milk. In how many ways can a person order a dessert and a drink? Okay, in this example, our choice consists of 2 steps. The first step is to choose the dessert, and it can be made in 5 ways. So, we can write the first step, or step 1, is actually choosing the dessert. And the other is to choose the drink. We can choose the dessert in 5 ways. So we can write pie, another branch for ice cream, branch for cake, pudding, and fruit. And we can choose the drink in 3 ways: coffee, tea, or milk. So I'm going to attach 3 branches: coffee, tea, and milk. And of course, I can attach these 3 branches to each choice in step 1. Okay. Now notice something very important. instead of just counting each branch, like we used to do in the previous examples, we can say that every choice of the dessert goes with 3 choices of the drink. So we can say we have 5 desserts with 3 drinks each. So that gives us 5 times 3, which is 15 different choices or 15 possibilities. Okay. And of course, after all that food, it would be very nice to get some exercise, like this guy in the 4th example. There are 4 different trails to the top of a certain mountain. Immediately, we can name those trails A, B, C, and D. In how many ways can a person hike up and down the mountain? If he must take the same trail both ways, he can but need not take the same trail both ways, and he does not want to take the same trail both ways. Well, in A, the step 1 is to choose the right trail when he goes up the mountain, so there are 4 possibilities. So step 1 is going up the mountain. 4 possibilities are A, B, C, and D. And since the condition is that he has to go back using the same trail, that means only 1 branch for the second step. Okay, so these are the choices when he goes down the mountain. So altogether we have 4 branches here, and each branch of the first step contains 1 branch of the second step. So 4 times 1 equals 4 ways. In B, he can but need not take the same trail both ways. Again, there are 4 possibilities for the step 1. Four possibilities for the step 1. And if he wants to go down, again, he can use the trail A, but he can also use the trail B, C, or D. And it goes the same for all the other trails. Again, we're not going to count each branch separately. We're going to say 4 possibilities for the first step and 4 possibilities for the second step. So altogether 4 times 4 equals 16 ways. Okay, and finally C. He does not want to take the same trail both ways. That means when he goes up the mountain, he can use 5 trails, A, B, C, and D. And when he goes back, he cannot use the same trail. So if he took the trail A when he goes up the mountain, he must take trails B, C, or D when he goes down the mountain. So B, C, and D. In this case, it will be A, C, and D, etc. So we can say 4 possibilities when he goes up the mountain and 3 possibilities when he goes down. So altogether 12 ways. Multiplying the number of possibilities in step 1 with number of possibilities in step 2, which we were using in our last 2 examples, can be more generalized, and that is something that mathematicians do all the time. If a choice consists of k steps, of which the first can be made in n1 ways, the second in n2 ways, and the kth in nk ways, then the whole choice can be made in n1 times n2 times nk ways. So basically, this rule tells us that if our choice consists of more steps than just 2, 3, 4, 11, 100, the principle is always the same: multiply the possibilities of each step. Of course, that is if you want to avoid spending eternity in counting branches one at a time. Like in this 5th example, if you're asked to count the possibilities, if you roll 4 dice, you can say that this choice consists of 4 steps. First, choosing the outcomes for the first die. for the first dice, dice 1. How many outcomes do we have? Well, 6. So 1, 2, 3, 4, 5, and 6. The second step is counting possibilities for the second dice, dice 2. Of course, again we have 6 possibilities, from 1 till 6. And I'm not going to write all the branches, of course. And this stays the same for the third dice and for the fourth dice. So it would be quite difficult, we must agree here, to calculate the branches one at a time and to name the outcomes like 1, 1, 1 and 1, 1, 1, 1 and 2, etc. So we're not going to do that. We can just say our choice consists of 4 steps if we refer to the multiplication rule. The first step can be made in 6 ways. The second step can be made in 6 ways. 6 ways, 6 ways. So altogether, if we want to calculate the total number of outcomes, we can say 6 times 6 times 6 times 6. And we can use the calculator here, of course, if you want to. And when we calculate this product, it comes out, it's 1,296 possible outcomes. Okay. Thank you.